Today's problem looks innocent, but it's actually designed to bait you into doing horrible algebra. We are given that w to the 7th equals 1 and w is not equal to 1, and we want to find the value of 1 plus w times 1 plus w squared times 1 plus w to the 4th. Now, if you pause for a second and try this yourself, the first instinct is almost automatic. Just expand everything. And technically, you can do that. You multiply the first two factors, then multiply by the third, collect terms, reduce powers using w to the 7th equals 1. But very quickly, the expression becomes ugly. You start getting a giant wall of terms. 1 plus w squared plus w cubed, and so on. And usually in problems like this, when expansion becomes messy that quickly, it means there's probably a cleaner idea hiding underneath. So instead of asking, how do I expand this? Let's ask, why were these particular exponents chosen? Notice the powers carefully. 1, 2, 4. Each exponent doubles. And whenever powers double like this, there is a classic identity that becomes incredibly useful. A plus b times a minus b equals a squared minus b squared. This identity lets products collapse into simpler powers, and that is exactly the trick here. Right now we have 1 plus w squared, and 1 plus w to the 4th. This expression almost looks like part of a telescoping pattern. The missing piece is 1 minus w. So let's multiply the entire expression by 1 minus w. Now we're not changing the problem permanently. We're just creating a structure that simplifies beautifully and later will divide back. Watch what happens. First, 1 minus w times 1 plus w. That becomes 1 minus w squared. Now multiply that by 1 plus w squared. Again, same identity. 1 minus w squared times 1 plus w squared becomes 1 minus w to the 4th. And then one more time, 1 minus w to the 4th times 1 plus w to the 4th becomes 1 minus w to the 8th. So this entire ugly-looking product collapses all the way down to 1 minus w to the 8th. Now we finally use the condition from the problem. Since w to the 7th equals 1, w to the 8th is just w. That means our entire equation is now 1 minus w times the original product equals 1 minus w. And here's why the condition w not equal to 1 was important. If w is not equal to 1, then 1 minus w is different from 0, which means we are allowed to divide both sides by it. So the 1 minus w cancels completely, and we are left with the original product equals 1. And that's the answer.